Hi, my name is Daniel Schrader, and in this video I'm going to show you how to write a useful bash shell script. Let's get started. I like to start my scripts with an author line to tell anyone reading this script who wrote it. Next, I like to have a date line with today's date, which is April 28, 2017, and a purpose line which will tell anyone reading the script, what does this program do? What's its purpose? Check the CPU utilization of the top 10 processes consuming CPU time on the server. If the CPU utilization exceeds the specified threshold, alert the system administrator via email. This script is going to do a lot for us. Next, we have our shebang bin bash line. This tells the Linux kernel to call the bash interpreter to interpret the rest of the lines, the rest of the commands in this file. Next, I'm going to have a section header for my variable declarations. And we're going to start declaring our variables. First, we're going to have a date timestamp variable, and we're going to use command substitution to capture a date with a 2-digit month, a slash, a 2-digit day, another slash, and a 4-digit year. Next, we're going to have a 2-digit hour, and a 2-digit minute in a 24-hour format, and the time zone that our script will be running in. Next, we're going to define a threshold, which is going to be 85. So any process that is consuming more than 85% of the CPU will be caught by the script. At least the top 10 of those processes will be caught by the script. The subject line for our email is going to have the host name, CPU consumption alert is utilization exceeded threshold, and the actual email that we're going to send is going to be stored in the root's home folder, and it's just going to be called email. Now, bash expands this variable to the process ID of the bash process. So when bash executes this script, it's going to write its process ID to the end of email. What this does is it makes sure that our email file has a unique file name. Next, we're going to define our mail program, and it's stored in /root/dsadm/bin/emailer. It's a shell script that I've already written that sends emails to me. Next, we're going to define the header of the PS command, so that we'll have some context for our output here, and that is not the header of the process command, or the PS command, but this is. So this is the header for the Berkeley version of PS, right, which is what we're going to be using in our script. And next, we need to capture the CPU used percentages of the output of the PS command. Now, it's good practice to use very verbose variable names. It makes the script much more readable. Anyone who's reading this script is going to thank you, because they're immediately going to understand what it's doing. There's going to be no guesswork in it. It is a lot more typing, but it's going to benefit you and whoever reads your script in the long run. Now, this variable is a bash array, and we can see that it is. Not sure how these extra characters are getting put in here, but okay. So we can see that this is a bash array because we have a set of parentheses, and then within these parentheses we're going to use command substitution to parse the output of the PS command. Now we're going to use fgrep to filter out our header line Next we're going to pipe the output to sort and do a numerical reversed sort on the third field of the output of PS. Next we're going to pipe that to head and print the first 10 lines of output. Now head will do this by default without specifying -10, but it'll help anyone reading the script to understand what head is doing. It's just more readable, so it's going to print 10 lines. Next we're going to escape the whitespace character so that we can break up our line, and bash will still interpret the commands correctly. Next we're going to call the tr command, which stands for transliteration, and what it's going to do for us is it's going to find all consecutive whitespace characters on the line, and it's going to truncate them to only one single whitespace character. The -s option means squeeze blanks. Next we're going to pipe that to cut, and we're going to cut the field using a delimiter of a single whitespace character, and the third field is what we're going to cut out. Next we're going to pipe that output to cut again, and our delimiter is going to be a literal dot, and we're going to cut out the first field of that output. Now at this point I'm going to write our changes to our file, and I'm going to execute this pipeline of commands to show you the output. Okay, so as we can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 zeros. That's because there aren't any processes running on the server that are consuming, well, any CPU time. Now that's not quite true, but it's minimal. So no process is consuming very much CPU time. This is not a busy server. So next, the next section in our script is going to be our main program. And again, I like to use a header to define the main program section. It just makes the script more readable for myself and anyone who has to read the script. Next we're going to use a for loop to actually iterate through the used percentages of the CPU that we captured earlier. So this is our control variable, CPU used percentage, in CPU used percentages. And what this means is that bash is going to interpolate or expand this array variable, and it's going to quote each item in the array. That's what this @ sign means within these brackets. Do, not in caps. And next we're going to have a conditional if statement within the body of this for loop. If the CPU used percentage is greater than the threshold, then we're going to echo our PS header to our email file, and actually append, more accurately, we're going to append the header to the email file. Next, we're going to call PS and pass it the AUX options, and we're going to fgrep the CPU percentage that we captured, CPU used percentages that we captured, but we're only acting on one percentage at a time, followed by a literal dot character. Now what this ensures is that the numbers that we're going to parse from the output of the PS command are CPU percentages. So we have the CPU percentage that we matched earlier with a literal dot next to it, because the PS command outputs the used percentages or used percentage numbers with a dot number, like a .0 or a .9 or whatever. Next we're going to pipe that output to fgrep, and we're going to filter out the grep that's going to be listed in our process listing, and we're going to append that to our email. Next, we're going to echo a blank line and append it to our email, and we're going to terminate our if statement and then terminate our for loop. Next, we're going to use another conditional if statement to check if our email file exists. So, has an email been written? And if it has, we're going to use sed to append today's date by using the insert command. So our date timestamp that we declared earlier to our email, and it's going to write that to a temporary file, and if that succeeds, it's going to rename our temporary file to our original file name. Next, we're going to call the email program and pass it the subject line of our email and the actual email itself. Next, we're going to delete the email file because we no longer need it. And we're going to terminate the if statement, and we're going to use the exit command to exit the program with a 0 exit status, 0 for true. Now I'm going to write changes to this file, and I'm going to set the executable permission to the file in a very specific way. And next, I'm going to demonstrate that our check CPU usage script works as it is written. We're also testing to make sure that it does. I test every script I write for syntax errors and such. So what we're going to do is we're going to call a dd command, and our input file is going to be dev0, and we're going to use a block size of 10. We're going to pipe that to a compression utility called bzip2 -9 for the highest compression ratio, and then we're going to write that file to the /temp file system as file.out.bz2, and we're going to run this process in the background. Okay, next we're going to execute our check CPU usage script that we wrote. Okay, it executed. Now it's time to check my email inbox. 12:48 p.m., which is our current time. I got an email. And here's our email. We have our subject line, Schrader-server1, CPU consumption alert, utilization exceeded threshold. We have today's date, April 28th, the time, 12:48 p.m., and Central Daytime is our time zone. Now we have our header, so we can interpret this output much easier. So it looks like the command that's consuming so much CPU time is dd, our dd command, and it's writing a bunch of zeros somewhere, right? So we can see that. The amount of CPU that it's consuming is 88.7% of CPU, so it exceeds the 85% threshold that we specified in the script. So this script is working.